No, page 6, you are answering page 6. Alright, so that is just agree and disagree. Alright, Hayden, we should be done. We should be done. So, do you think temperature is the measure of something, how hot or cold it is? Yes. Hey, what about when something heats up, it moves faster? And when yes. Okay, we are actually going to see evidence of that today in 2 models, okay? Alright, why do things change temperature? Why do things change temperature? We are going to answer that question. Okay, go ahead, Dolores, and read that for me.
To help us understand this question, we'll take on the role of students on the science and work to solve the problem with the heating system in the school. First, we'll watch the video breaks it down for them to help find your way and the heating system problem.
Alright, so we're going to watch a video message that helps us solve that problem. Hey, as you are watching the video, you are going to answer 3 questions. The first, how are heating systems similar and how are they different? What questions do you have about how heating systems work? And which heating system do you think will warm the school more during the winter? So, for our investigation question, we are going to have a school that needs heating. And we're going to just think about if this school in the winter, because it's going to be cold for the rest of the week, and the heat went out. We have to talk about what are ways we can heat up the school. Yes. Baby, not right now. Alright, let's watch this video. Jaylen, watch the video.
Tired of being cold? Sign our petition to make Riverdale fix the broken heating system. Hey, want to sign our petition? Sure. Thanks. Hey, Jesse, lunch is almost over. You ready to go? Yeah, let's go. We got a lot more signatures today. I can't believe this. It's actually 11 degrees Celsius in here. Transmission, please. 51.8 degrees Fahrenheit. That's cold. Yeah, it's the coldest indoor temperature reading this week. Look, I've been collecting data. Well, you can go tell the principal all about it because we finally have 11 signatures. All right, let's go.
Just a friendly reminder, this week's pep rally will be Wednesday at 7:30 p.m. on the football field. There's only 1 week left for this year's fall food drive, so let's make this one count. Kayla, Jesse, how can I help you?
Mr. Chang, I've been measuring the temperature inside every day, and it hasn't gone above 13 degrees Celsius. And today, it was only at 11 degrees Celsius. I think there's a serious problem with the heating system. The problem is that it's broken. We have a petition signed by 100 kids at school saying that we need to get the heater fixed. We hope they'll take this matter seriously.
I can do better than that. How would the two of you like to help me pick out a new heating system?
For real?
You all know the heat was broken. You want to see the options?
Sure.
Dylan, run that. Pay attention.
What we have here are two systems to heat the school using water that is at a higher temperature than the air in the school.
Interesting. I always thought heaters just use hot air and move it around.
The first proposal uses a water heater that heats a small tank of water to 39 degrees Celsius every day. Then that warm water is pumped into a bunch of pipes that heat the school. In the evening, when the water cools down, it's pumped back into the tank and gets reheated for the next day.
That is so smart. This one's my favorite.
Well, when you hear both of them. The second proposal uses a large reservoir of warm 30 degrees Celsius groundwater. Every morning, water from the reservoir gets pumped into the pipes that heat the school. Then, in the evening, the cool water is pumped out to make room for the warm water in the morning.
This one's really cool too. I don't know. How can water from the ground be warm enough to heat our whole school? Well, if the water is warmer than the air temperature. I guess, but I don't even see how the heat from the water could get into the air for either system. Water and air are separate things. How would the heat go between them? That's a good question. Maybe... Actually, I don't know either.
Thank you for your help. I'll email you the plan so that you can take a closer look. I love hearing input from students, but lunch is over. Time to class.
But we'd love to help more. Maybe me and Kayla could go research heaters in the library.
Nice try. Off to class.
Jesse, I have a camera on your screen. I know.
Okay, so I want you to look at that next page, which is page 7. Look at page 7. And I want you to discuss with your partner or your table off back which one you think will be the best. Which machine you think will be the best for heating the school. Okay, so what is happening now? We can't answer the question yet. That is our investigation question. What is happening in the air when the school gets warmer? But ultimately, we are going to be answering the question, why do things change temperature? So you are going to see this diagram again. So we are answering again what is happening in the air when the school gets warmer, because whatever heating system we choose somehow has to heat the air, but we have to know how to heat the air. Alright, so we will begin our investigation by speaking about and discussing the school heating systems we learned about in the video. Okay, now I want you did what you noticed and you wondered. Now I want you to answer these 3 questions on your somewhere in the white space on page 7. How are they similar and how they different? What questions do you have? And circle the heating system you feel will work well. Baby, don't worry about it. That's the hand of it. That's just water. 3 minutes to answer these 3 questions. Guys, it's 3. The 3 group. Alright, 35 seconds. Alright, looking around the room, y'all are pretty much done. Alright, so now we are going to do an actual model. So we are answering the question, how is something different when it is warmer or cooler? First, you need to know how things act differently, especially water when it is hotter or colder. Okay. Wait, when you just taking a stick out of the fridge, what is it like? Where is it properly? So when you take the stick of butter out of the fridge,
It's cold. It's cold.
is it harder or softer?
Hard. It's hard. It's hard.
Yeah. What about if you let it sit out? It's softer. Okay, so as it gets warmer, it is softer. Sit up, Jalen. Sit up, Jalen. Sit up. Okay, the investigation question asks how something is how something is different when it's warmer or cooler because you'll be testing out and thinking about how different things can change temperature. In this unit, you'll also start to think of what is happening to molecules as they get warmer and as they get colder. Huh? In a way, yeah. Alright, what are some other examples and ideas about how things are different when they get warmer or cooler? Ellen? An ice cube. An ice cube, what else? Boiling water. Boiling water, what else? What else? Huh? Water starts in the gas starts in there. What else? Huh? Chocolate. Okay, what y'all are talking about solids and liquids. What else? What about something that's warmer and gets colder over time? Wax. Okay. Are there some things that think about phase change? Because y'all learned that last year. Well, what about us? What happens if our body gets too cold?
You get bumps on your body.
No, I'm talking about couldn't get cold.
Or you get sick.
What happens when you die? Your body turns cold and what else? What happens, Maria? What Maria said loud? You just said it. Your body does not move. So something is happening. There's a correlation between energy and when you get warmer or cooler. Okay. Today we are going to investigate how water is different when you add food coloring to a cup of hot water versus when you add food coloring to a cup of cold water. Okay? Yes, I got it. So, we are going to be very careful because we are going to be dealing with hot water. So, you are going to have hot water and cold water. We are going to make sure our cup is full. And give us some of the yes. Okay, one person from each group come up and bring your cold water.
Get in line.
Well, look, you can do it yourself.
I don't know, touch it and see.
Do it to the top of
Holy
the
water.
Do it to the top.
You need cheese in your life.
Tabori.
You gonna get canceled.
You finna get put out. Yeah.
Puedes cuarto el vaso está por ese caliente. That's hard, don't That's hard.
All right, Evelyn, come here. Come here. Go in the closet and get that cup from the Keurig. It's a cup from the Keurig that's full of hot water. The black thing. Yahari, pass out all the cups that say H.
What are you talking about? Es mi color. ¿Qué pedo? Está caliente. A ver, ¿qué guapo te lo echas en el ojo? Es como piscina. No, mentira. Esa mierda está caliente. Es que son mujeres, vamos a ver. Porque cocinas. ¿Sabes hacer tortilla? Yo también. Sí, yo sí sé, pero son las esa mierda no lo puedo hacer, yo lo hago con la... Sale bien. Uy, cosas como darle vueltas. Sí, con la mano. Me quema. No me huele feo.
Okay, if you have already been given hot water, take your hot water and cold water, pour out the cold water into the sink to make sure your hot water and cold water are somewhat equal. Do not pour it into each other's cup. I didn't say that. I said pour your cold water into the sink to make sure your hot water and cold water are the same level. Oh, Dylan, I'm gonna give you some more. And then once you have your hot water and cold water as the same, go ahead. And you are going to add in food coloring. Okay? Do not move the cup. But I want you to answer questions on page 8. Okay, page 8. What do you think is going to happen to the food coloring? Predict before you add in that food coloring. Go ahead, page 8.
I think the food coloring, I just say darker and then the other one is going to get lighter. ¿Qué pasa si le echas agua muy caliente a una hoja? Te manchas las manos. Veneno, no creo que... Uy, calentó el agua en el vaso, anda. No ese café. Con no. ¿Cómo se dice? Café y té. It's not equal. That one has more. That one has more. Yo en la casa estoy tranquilo, solo dormir.
Alright, these are thermometers. You are going to use
Si me
a,
quitan el teléfono, si me
you are going to use a thermometer to measure your hot water. Try to keep it as flat as possible, so don't move it once you have the equal amount of water. You are going to put the thermometer in the cup for 15 seconds. And wait 15 seconds. 15 seconds. Stop. Measure the cold and the first.
las botamos. Tienes que hacer un milímetro.
Yeah, take it out after 15 seconds from the cold water, then put it in the hot water. Measure the temperature of both. Yeah. Yes. Mercury is down. Mercury is down. Put the mercury side down, and you need to, and you need to look at the water.
What does this say?
Do it in Fahrenheit, so where did it stop? Make sure your water is staying still when you are measuring.
Sí, se ve.
Stop hitting the thing.
Agarrame el huevo. Agárrame. Juega rojo. Juegas el juego de ping-pong. Juegas el juego de tablero.
Once you have taken the temperature of both, I want you to add, first of all, do not move the water. Keep it still. I want you to add in 2 drops of food coloring to each. And see what happens with that food coloring.
De cold water. Cold water es 72.
I say multiple times, do not touch the cup. Put in 2 drops into each. And then tell me what happens to the food coloring. What happens to the food coloring? 2 to each. Huh?
Mi gata me oriñó porque estaba embarazada. ¿A vos te gustan los gatos? Los gatitos pequeñitos. Mi gata está embarazada.
Yeah, 2 in each cup. No. You do not have to mix it in. I just want you to tell me what happened to
Digo
the
que le eches 3.
Thank you.
Este es más rojo. Mira. Imagínate. Esto se ve más rojo que aquel. No. Este se ve más rojo que este. ¡Ah, mira! Mira. El músico aquí está cayendo. Ya. María. Mira, ahí todo está cayendo. Y es que no.
Just pretend. Okay. So we're gonna wrap up in 5, 4, 3, 2, 1. So what do we notice about the food coloring in the cold versus the hot? What happened, Evelyn?
I noticed that in the cold water, the food coloring doesn't mix. They have a layer. They have a layer of food coloring on the top and a layer of food coloring on the bottom. But in the hot water, the food coloring it dissolves equally.
Okay, anybody else?
I'm noticing. Sort of like for everything, because like when I had put it in the cold water, it had like the dye on stayed on top and it slowly came down to the bottom. But I was going down to the bottom. It didn't make sense. But like the hot water, as soon as I put the red dye in, it automatically went down to the bottom.
Okay, that's what I want to hear. So we noticed that the food coloring moves faster in the hot water than it did in the cold water. We noticed that the food coloring moves faster in the hot water. Why do you think the food coloring moves faster in the hot water than it did the cold water? Somebody other than them. Why do you think the food coloring did what it did? Why did it move faster in the hot? Roselle? Ask me if you want to talk to me. Why do you think the food color moves faster in the hot water than it did cold water? Caleb? You gotta talk louder. Huh? When something is what? Heats up? Okay, Caleb says when something heats up, it moves faster. Okay, what else? Let's expound on that. When temperature is high, it moves faster. Say it loud. Thank you, Briasia. Very good. Point for you. That's what I wanted to hear. It has more energy. Alright. Okay. Go ahead and answer that follow-up question if you have not. The one at the bottom. How does the temperature of the water affect the movement of food coloring? I wanted a CER. I don't have none. No. I needed a CER. Use the graphic organizers in your caddy to help you. Go ahead.
I thought that back was the main
on our initial ideas we have to see if the investigation that we looked at confirms our thinking or changed our mind. Remember our investigation question, why do things change temperature? And we're looking at how is something different when it is hotter or colder, warmer or cooler. Hey, reagent answered that very question for us. Things that are warmer have more energy. Okay? Think about what I just told y'all earlier. When you die, you don't have no energy. So your body is cold. Okay? Alright. So today you worked on collecting evidence to answer this investigation. How did the experiment change your thinking? Go ahead and answer that as your exit ticket for this lesson on page 9. For this lesson on page 9. And when you finish, put your thermometer and food coloring in your caddy. Okay, put your thermometer and food coloring in your caddy. And we're going to go on to the next lesson. Turn the page. Go ahead, Dolores.
I'm just like the mother out here.
Okay. Thermometer and food color in the caddy. Alright, and then we're moving on to 1.3. Minutes. Good. Let me see your question. Jenna, you answer the question?
Let me see your previous one. You don't have nothing in here, yours. Wait. This one, page 9.
No. It's your sentence started. So what you need to do is you need to write, repeat this part. Escribe en español aquí. Okay, this table. Let me see. I'm going to try to go through that.
I'm done.
I need this CR. CR. questions to go. Once you finish, get your Chromebook for lesson 1.3. Bridget, if you see somebody's name, give it to them, please. Make sure you have the right one. Yuri. Evelyn. All right, once you get your Chromebook, go ahead and log into Amplify. We are on thermal energy. We are in a new unit, so make sure you are on the right. Yes.
Hola.
All right, go ahead and log into Amplify. Play on this. Play on this. Play on this. Play on this. Log in. Okay, so what we're going to do in the new lesson is we are going to try to repeat this in the sim. We're going to try to repeat what we just did by hand in the sim. Okay? So that is our objective for today. I can use a digital model to explain molecular movement. Y'all told me that the molecules move based on temperature. They move faster. You told me that food coloring spread out and move faster based on temp. We're going to see if we can replicate this in that digital model. Okay. All right, so go ahead to the thermal energy simulation. Amplify thermal energy, click the sim. And I want you to explore that for 10 minutes. What can you do and run? What can you do and analyze? I didn't put it in Google Classroom yet as a link, so you go straight to Amplify. Clever, remember, go to Clever first.
Mañana lo traigo. Pero lo tengo. Tengo 3 2.
Make sure you link
Tengo 5 helicópteros. Tengo 2 Supra. 3
Thermal energy, that's our new unit name, thermal energy.
¿Verdad que todas las mujeres son iguales? Sí.
And you are going to write this down on your warm-up. What do you notice is run, and what do you notice is analyze?
¿Son bolas? No. ¿Qué pasa si le meto otra? ¿No queda? Hace una piedra.
Y'all the right one? Thermal energy? Thermal energy tip. 7 minutes. 7 minutes. I need something written down on what you can do in both. Go to clever. Then go to the thermal energy. Huh? Yeah. And this is just you exploring the film. This is your first time with it. 7 minutes. Going to Amplify if you are doing I'm going to give points to people I see that are on the right thing and that are exploring the STEM. They're good, Yuri. Get on it. You're the last one until brain break. Go ahead. I see people playing with the STEM, but they're not writing down what you can do and run and analyze. I need you to write down what you can do and run and analyze on your warm-up. Four minutes. And then I'm going to ask one of y'all to go up and do some things with the STEM. To use a model to gather evidence. What y'all got for me? So I need one and a lot. But that's okay. Dylan is going to model for us. So Dylan, you go ahead. You have my mouse. No, yeah, you can lay some. There's 3 of them. Okay, so Dylan, and I might call on you next, so make sure you are paying attention. How do we select the size of the sample? What do we press first? We're going to add samples. I need everybody to do that in the sim. Click add. We add sample. I need everybody to be here with me. Don't tell me you don't know how to use the sim. Add sample. What do you want to click? Medium. Can I add more than one sample? Yes. Yes, very good. It should be that. This is the way to add more than one sample. Oh, there we go. We can add more than one sample. Okay. Can I push samples together? How? What do I do? I can drag them into each other. That's what y'all said, like this. How do I move them? Dragging them away. Very good. Okay, let's go to, are we in run or are we in analyze? We are in run. How do I add energy to my sample? I'm pressing the plus. Okay. How do I remove energy to boards from my sample? So just the boards. Press the minus. Very good. Press the minus. Okay. What do we notice about adding and subtracting energy in the sim? When I subtract energy, what happens to the temperature? It goes lower. Okay. Let's reset. What can I do in analyze? What can I do in analyze? Measure the thermal energy over time. How do I do that? Let's do that for me, Lindsay, because I don't know. I didn't do it yet. So go ahead. Let's do it on mom. Yeah, girl. Come on. Come on. Go do it. Yes, you can. Come ahead. Don't be shy. I didn't do it yet. Go ahead. Go to the mouse. And how do you add it over? Do it on top. Yeah, it's not. How do we do it though? Because my window is not supported. How did she say we do it over time? Huh? Tell me what? No, that's why y'all need to stop talking and pay attention. Reasia, how do we change? Huh? No. Come on, that's why we need to pay attention. Come on, baby. How do you change it over time? Over time? How do I track the temperature over time? In which one? In which one? What are analyze? Alright, she's right, just because you didn't hear her. You are in analyze, you can't see it on mine because for some reason it won't work on my board. But you are looking at it over time by dragging. See Caleb's screen? This is in analyze. This is in analyze. Is that right like that? Okay. Remember that the simulation is a model of the real world. And in the sim, we are going to look at the molecules. What's a molecule? Yes, the very smallest piece, okay, that are atoms or particles that are make up of the bigger. Remember, y'all have a glossary in the back of the book in Spanish and in English, okay? All right, the sim portrays molecules on a much smaller scale. We are only focused on molecules in the unit, okay? So we are looking at molecules, not atoms. Molecules are smaller. Sometimes you will hear, well, atoms are the smallest thing, but molecules are a little bit. What atoms are made of. Okay, the sim only shows a relatively small amount of molecules, okay? Y'all, and I keep interchanging molecules and atoms, but this is an atom. This is a molecule, okay? It's a group of atoms. Take forward, please. Take forward. Okay, you said that. Let's watch the video to make sure we get everything.
This is the thermal energy sim. You'll use it to learn about temperatures and energy in different substances. To begin run mode, use the Add Sample button to add a small, medium, or large sample of a substance. You'll see a model of your sample here in the box. You can add energy to the sample using the plus sign, or remove energy using the minus sign. Notice that when you add energy, a hot coal appears below the substance. When you remove energy, an ice cube appears below the substance. In the top right, you can turn the View Kinetic Energy toggle on to see the kinetic energy in the sample.
That is something we did not do. Okay, the video is showing us. We can see the kinetic energy. Okay, like James said earlier, when we add kinetic energy, what's going to happen to the temperature? It will rise.
The higher the kinetic energy gets, the brighter yellow the sample will become. Use the controls at the top right to pause the sim, change the speed, or reset and start a new run. Let's add another sample using the Add Sample button.
How do we reset? How do we reset the sim? Stop right. Stop right.
You can add or remove energy from each sample, or drag the samples together. When you put two samples together, you can turn on the View Energy Transfer toggle to see the transfer of energy between them. Press Analyze to track how your samples changed. You'll You'll see graphs showing changes in thermal energy over time and temperature over time, with a different line for each sample.
Okay, so I couldn't show that on my board, but you have thermal energy over time and temperature over time. We will be using both in this unit.
You can view one sample at a time, or both. Use the replay button in the bottom left to show the graphs running over time.
Let's think about this. If with water, if I put water on the stove, soon as I put heat on it, what's it gonna do? It's gonna start boiling over time. What's gonna happen? It's gonna do what? Pressure? Yeah, get hot and do evaporate. It's gonna change to a gas. So it is very important that we look at energy over time, because when it's there immediately, it may not change phase. Okay, but over time, it may be something totally different. All right. Just like a gas. When you freeze a gas towards, what happens? No. When you freeze a gas, y'all remember that from last year, what happens? When you freeze a gas, what does it turn into? A liquid. It turns into a liquid, and then eventually over time turns into a solid. So that's why it's important that we look at this sim over time. Roselle, tell me.
If you make a mistake or want to start over, go back to Run and press the Reset button in the top right.
Alright. What do the small circles represent? Molecules. Good. Molecules. And this atoms, but mostly molecules. There are groups of atoms. Everybody look at the board that I wrote over here. I have atoms that are grouped together. This is a molecule. What does that represent? No, this is a molecule. Look. This is an atom, this is an atom, this is an atom. Grouped together, it makes a molecule, okay? Which is water. So a group of atoms join together in a particular way. A group of atoms join together in a particular way is a type of atom. And, oh, I just drew that, please. That's it. Okay. I just drew that on the board. This was 5 minutes ago. 95 minutes ago. This. When I went over there. Okay. Each circle represents one molecule. Okay? Now, of course, they're very small. We can't see them, but they represent on a larger scale than their size in real life. The sim shows a small number of molecules that you can easily observe. We have billions of molecules. We can't see all that, so we're going to watch it in the sim. Everything is made of molecules. Molecules are made of atoms. Got that? Say that with me. All right. Things are made of molecules or other atom groups. Okay. What did you observe in the first investigation? What could have caused the difference between how the food colored? What's going on with the molecules in the last investigation? The molecules moved around more freely in the hot water. Say that loud, okay? The molecules moved around more freely in the hot water. The molecules moved around more freely in the hot water. In the cold water, what are they doing? They are coming together. So we are going to try to replicate this in the sim. We are going to model the food color freak investigation. That way, look, we know that y'all stated, based on what y'all learned last year, that energy causes temperature to rise. But on the leak test, you can't just say that. You need to use evidence. You need to use evidence. So I need you to try to replicate this in the sim, okay? 10 minutes. Go ahead and try to replicate Replicate the cold water and replicate the hot water. We are on page 12 in your notebook. Page 12. You just learn how to do the skill. You work with your group. Work with your group. Work with your group. Come on. Come on. Work with your group. We're going to try to replicate what happened in the cold water. La frío, agua, caliente agua. Sí. And you are going to answer page 12. You are going to answer it on page 12. This is your first grade of the third 9 weeks. Lesson 1.2 and lesson 1.3. I'm going to be looking at y'all books today.
Pelota,
We will help you. Use your classmates to help you. Eight minutes.
Ponelo caliente, ponelo frío. Tengo la caliente. Así lo pongo aquí. Caliente frío. Caliente frío. ¿Cómo es eso? No, pone aquí.
Okay, y'all. When you in the lab in 1.2, you took the temperature for a reason. So let's get ahead. A good question. You should have 2 samples. What I would do is I would put one temperature at the cold water temperature and one temperature at your hot water temperature. How do you do that? You add or subtract what? You add or subtract what? To make the temperature hot or cold. What are we adding or subtracting? Heat. Say it loud. Energy, kinetic energy. Very good. Very good. Let me give you a point. Some of y'all gonna get lunch on me because I'm adding your points from second 9 weeks since we didn't get to the reward second 9 weeks. But some of y'all, I don't know. You'll see that brain break. I'm walking around seeing who's focused and who's not. It's behind you. So I need you to do page, remember 12 and 13. We're going to do page 12 and 13. So you adding 2 for your E, Hayete, and you're repeating what happened and that and that. 3 minutes. By now you should know the reflection. Very good, very good. Y'all doing good. You're weak, baby. I need you to try, love. I need you to try. So based on the reflection, I can tell who's paying attention and who's not. Okay, what evidence did you find in the STEM activity to help you with this question? What evidence did you find, Peyton?
When I had added more to my sample, the molecule knew more.
Okay, very good. She said the evidence came from her adding the heat. So how is something different than when it is warmer or cooler? Discuss with your group. What did you choose? What did you choose as a reflection to help you answer this investigation question? How did evidence from the STEM help you? Talking so hard, y'all got the same thing. Y'all was on the right. Come on. Discuss. Why? Why, Dolores? Why? Why you saying that?
I say, no, listen. I say it's B. No, I say it's B because the hot water is affecting the move color way more. And maybe the move has to move out like maybe the cold water, the water can move slowly and get close together. So it means, well, what is come up with this stuff all together.
Cause you copy it off your heart.
But I'm not, why you doing?
Yeah, go ahead, Creation.
I chose beef because fruit stimulation is temperature of water more frequently like gas and stuff. But when it gets cold, cooler, the molecules start to sweeten up.
Yep. When it was, and it didn't take us 10 minutes. When it was hotter, okay, our molecules moved a lot faster. Okay, that is a key concept. Very good, Creation. Very good, most of the class. When a thing gets colder, its molecules are moving slowly. Okay, exit ticket. You're going to put your name on this note card. You are going to choose two answers. Yes. I'm giving you a note card and you are going to put your name. You do not have to write the question. You can put two answers. Yeah, you can just put the letters. Take one, pass it around. Okay, you're gonna have 5 minutes for that. Oh, my bad, y'all. Actually, it shouldn't take you 5 minutes. And when you finish, put it in your, what's that thing called? What's the thing? Caddy. When you finish, put it in your caddy. Make sure your name is on it. Please read carefully. I don't mean to call no names, but Dylan wrote the answer in our pretest. He wrote the correct explanation but the wrong answer. Y'all, a lot of y'all put, for the pretest, you put, oh, it will be B because I want my dish to be not too hot, not too cold. It didn't ask you that. It asked you which dish was the hottest. But y'all read the question. Make sure you read carefully. Read carefully. It's 2 that's correct. I don't remember exactly. I'm not going to tell y'all. Select 2 and then put it in the cave. Select 2 and put it in the cave. You can write questions, but you don't have to. Just put the letters and put it in the cave. Alright, when you're done, go to the back of your book for homework. You have an article to read and annotate. Page A1, rip it out. Page A1.
Tenemos que escribir ya.
Is everybody finished with the exit ticket? We are ripping out page A1. Put it in. I put it out there. met today's success criteria. Talk to your group, make sure they met today's success criteria. They know this.
Solo dije, no. Dime tú si está bueno, por favor.
Adrian said they made success criteria. Let's snap it up for Adrian.
Cállate.
I don't know who. What about my middle group? Y'all met the success criteria? Did everybody get your group? What about Jalen's group? Y'all both met the success criteria? No, what do you mean, baby? Did you not know how to use evidence for the cell? Okay, did you know that temperature measures kinetic energy? Alright, Dylan, can you pick up everybody's books for me? Make sure you have ripped out your homework. What is your homework to do with this article, Flora? Annotate. Thank you. Yes, and you can ask questions. I want y'all to add in questions. Don't just annotate the summary. I'm sorry, y'all think about this. Alright? We got 3 minutes left, so. Zanaya's table, go ahead and plug in Chromebooks with the number out. Chromebooks with the number out. Zanaya's table. Zanaya's table. Yuri's table. Go ahead and plug up your Chromebooks with the number out. Brain break officially starts in 1 minute. The bell rings. Stop my recording, Avery. Okay, Tavor's table, plug up your Chromebooks with the number facing out, please.
I won't record while I can see it.